Here's a thing that happens in pretty much every game you've ever played. You click somewhere, and the character just goes there. Around the walls, through the gap, no fuss. It feels like nothing. But something worked all that out in a few milliseconds for every unit on the screen, every time you clicked. That thing is A-star pathfinding, and you can understand it completely just by watching it think. So let's start with the dumbest possible way to find a path, and improve it until it turns into A-star. Pretend the start is a leak, and you're pouring water into it. It spreads one cell in each of its 4 directions, then one more, then one more. It doesn't know where the goal is, and it doesn't care. It just fills. Watch the edge, that ring of yellow. Cells the water's reached but hasn't spread from yet. The frontier, the blue behind it is settled. Every step, we push the frontier out by 1. It pours out through the slot in the roof, down the chute, and eventually, there, it touches the goal. Here's the trick that makes this useful. Every cell remembers which cell the water came from. So from the goal, we just walk backwards, hand to hand, until we're home. That's the whole path. And because every step costs the same, and the water spreads evenly, the first time it touches the goal is the shortest way there. Guaranteed. The flood can't be wrong. The problem is what it costs. 311 cells for a path 28 steps long, because it had no idea which way to go. So let's give it an idea. We can't know the real distance to the goal. That's the thing we're trying to find. But we can guess how many steps would it take if there were no walls at all. Over and down. This is called the Manhattan distance. Every cell gets a guess like that. And now here's the change. Instead of spreading evenly, we always spread from whichever cell on the frontier has the smallest guess. The one that looks closest. That's it. Watch what that does. It's not spreading anymore, it's aiming. Straight at the goal. 61 cells instead of 300. But look where it went. That door on the right looked closer, so it took the door into that chute. Meanwhile, the real way out was that slot in the roof, right next to where it started. 34 steps. It got there, but 6 longer than the flood found. And it has no way of knowing that, because it never counted how far it had walked. It only ever looked forward, fast, and confidently wrong. And the flood had the opposite problem, careful and slow. The fix is almost embarrassingly simple. Use both numbers. Every cell on the frontier already knows 2 things. How far it's walked to get here, that's the flood. And how far it guesses is left to go, that's greedy. Add them together and you've got a guess for the whole trip through this cell. Now spread from whichever cell has the smallest total. Not the shortest so far, not the closest looking, the smallest sum of both. It heads right, like greedy did. But now every step it takes, the walked count goes up. So the whole room gets more expensive, band by band. 22, 24, 26. And instead of committing to the chute, it goes back and tidies up everything cheaper first. It just always does the cheapest thing. And once the total hits 28, the slot in the roof is as cheap as anything else. Through it goes. And out on the roof, every step is 1 more walked and 1 less to go. So the total never moves. Straight to the goal. Same 28 steps the flood found. 141 cells instead of 300. That's A-star. The flood's guarantee with a sense of direction. Now let's slow all the way down and watch it make 1 decision at a time. Here's a tiny version. 1 wall in the way. Same rules. We begin with the start on the frontier. Walk 0. Guess 5. Total 5. Take it off the frontier and look at its neighbors. Each one's a step further walked, with its own guess. Right and down come out at 5. Up and left, 7. On they go and the start's settled. Lowest total on the frontier, a tie at 5. And the same guess on both. 4 and 4. Nothing to choose between them, so we take whichever we found first. We go right. Up is 7, down is 5, and the wall's a wall. 5 again, twice over. And this time the guess does decide. This one's guess is 3. That one's is 4. Smaller guess wins, so we go down. Then the other 5. and now everything at 5 is used up. The frontier's best is 7, and there are a few of those. Ties again at 7, so the closer guess wins. Down first, into the corner. That opens a 9. Worse, so we leave it. 3 cells are still level. Same total, same guess, so we take the one we found first. That's up. And it walks the top row, skirting the wall. 7, 7, 7. Round the corner, down, goal. And the arrows. Every cell's been pointing back at whatever reached it all along. Follow them from the goal, and there's your path. 7 steps. Notice what we never touched. That corner past the 9. The long way round, under the wall. It got close, learned, and let go. Now about that guess. The heuristic, if you've read about this. Why did A star land on the shortest path, and not just a decent one? It comes down to one rule. The guess is never allowed to be bigger than the truth. Over and down with no walls can only ever be too small. Walls make things longer, never shorter. Now watch what that buys you. Here's the whole A star run again. Stop the instant the goal came off the frontier. It came off at 28. And everything still out there says 28 or more. So nothing waiting could have reached it any cheaper. The moment A star pulls the goal off the frontier, that path is already the shortest one. And the easiest way to feel that is to break it. So let's turn the guess up and down. There's a dial for it. Trust it 0, and the guess is ignored. You've got the flood back. The same spread, the same guarantee. Trust it exactly once. And that's the A star we've been watching. Same path, and it looks at less than half as many cells. Now trust it 3 times as much as the walk distance. It's greedy in a jacket. Faster still, 85 cells. And there it goes, down the chute again. 34 steps, because now the guess is bigger than the truth, and the total's lying about how far things are. That's what an overconfident guess costs you. Put all of that together, and the code is shorter than you'd think. The frontier, the open set, if you've seen it written up, is a to-do list sorted by total. The start goes in first, and every cell remembers 2 things: how far it's walked and who it came from. Then we loop, pull out the smallest total. If it's the goal, follow the arrows back, and we're done. Otherwise, look at each neighbor, 1 more step walked. If that's better than any way we've reached it before, and the first time, it always is. Write down the distance, write down who we came from. Then put it on the frontier with its total, its guess, so ties go to the closer one, and a count, so the rest go to whichever we found first. And that loop was never about grids. All A star ever asked was, what's next to where I am? How far is that? And roughly how far is the goal? Give it a roadmap, and neighbors are the next junctions. Walk distance is how far you've driven, and the guess is the straight line. Same loop, same answer. Next time you click and something just goes, that's what it did on the way. That is A star pathfinding.